Everybody, this is the tutorial to model the screw or main screw for the vice handle. So we're going to start off by doing a revolve in the front view. And make sure that you're in parallel projection, or otherwise you get that horizon that you just saw. And we're going to draw this part starting at our origin. And we'll start with our typical two construction lines. Oops. Turn object snaps off there for a sec. Okay, so I've got two lines. The left side is going to be the head of the screw, and the right side is going to be the tip. The first thing I'm going to do is draw offset this vertical line for the overall length of the part, which is covered by a note in the sketch. So it says not including the 118 degree point, the overall length is 6.5. We're going to offset by 6.5 the vertical line. That gives us our overall length. Let's go ahead and use trim. Trim this off the scale and we can zoom into the overall length of the part. The line that's drawn here is going to represent the axis of rotation for our revolve. Okay, and we'll start on the left side. So the head of our bolt is 3/4 of an inch in width. So we'll go 0.75 and offset a line from left to right. The diameter of the head is also 0.75. So we're going to offset that by half because we're revolving it, so it's 0.375, and we'll offset the center line up. Now if we trim those lines up, we now have the shape of the head. Now the head has a fillet on it, and we're going to go ahead and revolve that fillet. I'm not seeing a fillet called out, size called out on the drawing that we have here, so let's set our fillet radius as 0.12, which is what the general note edge radius is on our standard print. Okay, so the next step is the shaft that's going to ultimately be threaded. So we want to make that thread at the major diameter, the shaft at the major diameter, and then we're going to come back and cut the thread into it. So our thread is a 0.625, which is a 5/8 -11. The major diameter should be 5/8. So we're going to offset. So we're going to offset 5/16, which is half of 5/8, 0.3125, and offset from center line up. And that gives us our major diameter. I'm going to trim off the line extension. And then our length of thread is actually determined from this corner here. So we're going to do another offset, and that offset is 0.85 or 850 thousandths. And we're going to offset to the left. So we have our threaded section, and then it necks down to the portion that goes into the movable part of the vice jaw. And that we have a tight tolerance of 490 to 495 thousandths. Typically I would split the tolerance on that, but I'm reading through Allison's notes and she is saying to model it at maximum material condition, which would be the largest of those two numbers. So we're going to do that so it's consistent with the tutorial that she made that's going to cover the GD&T on this part. We're going to offset by half of 495, 0.2475, and we'll offset from center line up. Now we can trim off the excess. And we should be left with a shape that looks like that. And actually we need to trim off that little piece. And we can trim off this. Now we need to put our angle on here. Let's select rotate, select the object we're rotating, we're going to hit enter, we're going to select our pivot point, and we need to go the complement of 59 degrees. So that would be 31 degrees. Alright, so now if we take and draw an arbitrary line out in the end, we can do a extend and extend out our 2 points. And then likewise trim off the piece we don't need and delete the line. Alright, we more or less have the shape we need to revolve minus a little arc shape here. And so the drawing says that it's 185 thousandths from this corner. So let's draw a line, and we're going to offset that line 0.185 to the left. So that's one edge of our arc. And then it's 220 thousandths wide. So we'll repeat our offset and put in 0.22 and offset the line again. So the partial arc, non-tangent arc, fits between those two lines. And the third point of the arc is the bottom of it is a diameter of 458 thousandths. So we offset half of that distance, which half of 458 should be 229. So 0.229, and we offset from center line. Alright, so now if we extend, we trim the length of that line, we have 3 points we can select on. We can pick on the intersection of these lines for the first point, the midpoint of this line for the second point, and this endpoint for the third point of an arc. So we're going to switch to arcs, and we're going to use 3 points. And make sure your object snaps include intersection and include midpoint. So we're going to go from intersection to midpoint to endpoint, and we get our shallow arc. We then can delete these other construction lines by just highlighting them and pressing the delete key on your keyboard. And then we come back and trim off the line segment that falls in between. And we also don't need this construction line anymore. I'm not sure why I was having trouble trimming that box out, but alright, so we're at a point where we can revolve this. We need to join this all into one entity. Now you can use polyedit or you can use a join command. You may actually be able to use a region command too, but I'm going to use the join command and select everything. And when you go hover over or select it, it should be all one piece. I'm going to go to an isometric view. We're going to select our solid revolve. So you're going to go to the extrude command, and you're going to pick the second option down, which is revolve. And we're going to revolve the joined body. We're going to hit enter to accept that. And you could use an object. The problem is it's all joined. So I'm going to use some coordinates. X coordinate, and we're going to put 360 degrees in. So that rotated it in the coordinate direction of what I had in X. Now if your gnome has changed different angle, your trihedron is pointing a different angle, you would need to pick the one that's going in the correct axis. So we're going to go to the conceptual, and you should have something that looks like this. Okay, and the first thing we're going to do is set up a couple sketches. So the first one, we're going to set up a sketch that's going to mimic the cross section of the thread we're going to cut, and we're going to use a helical path for that. So we're going to go back to wireframe. This way I can pick this top quadrant of the model and create a line that's horizontal. That horizontal line represents the major diameter of the thread. If we go to our chart, the minor diameter of the thread for a 5/8 11 on an exterior thread is 0.5168. So if I were to take the major diameter of 0.625 and subtract the 0.5168, I'm left with a difference of 0.1082. If I divide that in half, that is the difference between the two, the major and minor diameter, 0.541. I am going to do an offset of that amount from the outside for the radial difference. Offset of 0.0541. Alright, so this is the major diameter, the minor diameter. I'm then going to draw a line from endpoint to endpoint, and I'm going to offset that by the pitch, which is 1 divided by 11. So it's 0.09, 0.09, 0.09. I'm just going to use 0.09. So I'm going to offset 0.09. This vertical line to the right. So if I were to trim this up, this blue box represents one thread pitch. Now remember, the thread pitch goes from the theoretical sharp to theoretical sharp, and the UNC thread has flats on it. So the next step I'm going to take is take the vertical line on the left, and I'm going to rotate it, hit enter. I'm going to pick our pivot point, and we're going to go 30 degrees. Now we're going to repeat that procedure on the opposite side. And do a rotate, the line on the opposite side, hit enter. Our rotation point's the top, and we're going to go negative 30 this time. Now we're going to go to the extend command, and we'll extend our angled pieces, and then we'll go to trim and trim off the tails. Now our spacing is off. The reason our spacing is off is, again, the pitch is between theoretical points that are above. So the thread pitch, the distance between this face and this face, is actually halfway between here. So an easy way to fix that is we're going to do a move. We're going to select the right hand side face, and then we're going to go from, and we're going to accept that. We're going to go from endpoint to midpoint and move it over, split the difference. We'll then take the trim command and trim off our tails. At this point we have the profile we need. We need to type the join command, join, and select these cyan entities to make them one. Now we've done the piece we need for the cutting profile for the thread. Okay, now that we have the profile established, we need to make the helix. For this information, we need the thread pitch and the diameters as well. Now you can choose to make the helix either at the bottom of your thread profile or the top. I'm going to make it at the top. And we're going to go up and use the, we're going to go to draw, select the helix command. And it's going to ask you for the center point of the base, so that's your one end of the helix. So I'm going to pick the center of the model. Okay, make sure you have your correct object snaps. Now it's asking you for, by default, the radius. And I'm going to select the top left corner of our profile, and that's where our helix will start. Because we want to, it's easier to attach it to the profile. You don't have to, but it puts it in the correct position. Now it's default, now it's asking you, what is the diameter at the opposite end of the helix? So the diameter is 6.25. So we're going to type D. We're going to put 0.625 and hit enter. Now it's asking you what's the spacing, and there's a bunch of different options. And one unfortunate thing about the helix is it defaults to counterclockwise. Because in mathematics, counterclockwise is a positive radian. So what we're going to do is we're going to first, we need to set a bunch of parameters. So we're going to set the twist. So you can type twist, or it looks like the hotkey is W. And we want to make sure that it says CW for clockwise for a right-handed thread. If you put counterclockwise, you're going to have a left-handed thread. So so you're going to type in CW or take for clockwise. That sets the spiral direction. Then it's asking you what's our spacing. Now there's axis endpoint, which is the other end of the spiral, which it'll just evenly space them between one and the other. You can tell it the number of turns or the turn height. The turn height is what we want, and the turn height is going to be your thread pitch, which is 0.0909 in reality, but we're not going to worry about that tolerance of the model. So that gives us the thread pitch that should give us 11 threads per inch. Now we need to set, it's asking you, the last parameter is the actual length of the thread. And we're going to go all the way to the center of the opposite end of the shaft and select it. So that gives us a helix with a 11 threads per inch pitch, and then here's our profile that we're going to drive along that, and we'll create a solid body that will be subtracted from the main solid body. Alright, so now we're going to go to the sweep command, and it's asking you what's the object to sweep, and so that would be your profile. We select our blunt triangle, and we're going to accept the default mode, which should be solid. Alright, now it's asking you for some information. There's alignment, base point, scale, and twist. We do need to adjust the alignment. We're going to press A for alignment. And is our object perpendicular to the path before the sweep? And we are going to say no. If we don't do this, it'll rotate our profile to be 90 degrees from what it currently is facing. Okay, and if you did draw your profile on the end of your spiral, you can just hit enter at this point. If you did not, you need to align the base points. So you select a base point on the profile, which would be this corner in this case. I should be able to take the default. Okay, back up to helix. Okay, so we've got the helix. Now, we use the edge geometry to draw our profiles, but this front edge has a 20 thousandths lead in. So now that we are done with needing to select that corner, we should put an edge chamfer on this edge prior to doing the threading. So sequence-wise, I wanted it sharp to develop the triangular profile and the helix, but now that we don't need that corner, we're going to go to the solid command, we're going to go to chamfer edge, and we're going to select this outside edge. And mine's defaulting to an inch chamfer, which is huge. So I'm going to hit distance, and I'm going to do a 0.02 by a 0.02. So that's a 45 degree 20 thousandths chamfer. And we're going to accept that, and we're going to hit enter. So we have currently, if I were to switch to conceptual, we should have a chamfer on this front edge. Okay, we're going to go back to TD wireframe, and now we're going to do our sweep. So you can do it in here. I'm going to go ahead and go home and pick on sweep here. It's under the extrude pull down. I'm going to select the profile that's going to be swept, hit enter to accept it. We're going to type alignment. It's going to ask, is it perpendicular to the sweep? No. So it's N. And then since I drew the helix in alignment with my path in alignment with my profile base point, I'm fine with that. So I don't need to change the base point. I just need to select the path, and it should generate a solid helix. So my helix is in cyan. So we now have a coil body that we can use to cut the base body. Alright, so now it should be a matter of selecting object subtract, and the solid that we're going to keep is the first thing you select, and we hit enter. And now we're going to select the solid we're removing material with. And I would kind of zoom in to where it's running off the part to the chamfer and select it and press the enter key. Now if you did everything correctly, you should end up with a helix that's been cut, thread into your model. So let's look at this in conceptual mode. There we go. We've got our thread. In reality, you would have some runoff there, but that's fine for graphical purposes. We have on the front, where did my model go? On the front, we have our thread going into our a chamfer leading into our thread. The only thing left is to put the hole in the head. Let's turn conceptual view back to wireframe. And as always, there's more than one way to approach this. I'm going to go to a front view. And I'm not sure why this keeps switching back to perspective. And we're going to draw our circle. Take our line with ortho from origin. Turn ortho on. Turn our object snaps off. And draw our line out to an arbitrary point. And we hit escape, and we're going to come back and draw another line from origin up. We then can offset a line from the line that's vertical from origin, 0.31. I'm going to select it and go to the right. So the endpoint of this line is where the center of our circle will go. And the circle is a 0.281. Actually, we're going to change the diameters by pressing D. And the diameter is 0.281. So we've got a circle where it needs to go. We can go through and delete this construction geometry because I don't need it anymore. I'm going to look at it in a 3D view. Okay, with our circle, we're going to do a press pull. And we're going to pick on our circle and drag it out some arbitrary amount. And then we'll press pull the opposite side. Some arbitrary amount. Now that'll allow us to do the subtract body. So we're going to select the body we're subtracting from, hit enter, and then select our two pieces that will be removed. And we're left with the hole in the middle. Alright, that completes this model for the main screw for the vise project.